there's real excitement in the field at the moment, and the BREATH consortium's really contributed in quite a large way.
For my lab, this was quite unusual to go deep into one field, because we tend to be involved in lots of organ researches of all different organs, but all of a sudden we sat with lung experts, lung doctors and patients, and that led us to realize what the real deep questions are that need to be solved to eventually help patients.
Our group works on regenerative medicine, so on the possibility of treating organs or tissue by improving their function through stem cells or tissue engineering or regenerative medicine technologies.
It was a really unique opportunity to be able to come together with other basic researchers to begin to think about how to accelerate lung regenerative medicine.
Through this collaboration, you have the opportunity to connect to these individual research areas, each with their own unique research expertise, and that way become more effective as a team than you can ever be as an individual.
One of the most important things is that this group of scientists has been united, and that we have funded the next generation of lung scientists.
The discovery that I'm personally most proud of is the discovery that of the protein osteoglycin that we found, and which we're now trying to get to the patient as a therapeutic product, which we found was able to restore, to regenerate tissue. And I think that's, of course, really exciting.
Now that we've identified that there's a population of cells in this part of the lung that can give rise to other cell types that comprise the lung, specifically the part of the lung that exchanges oxygen, we can start to think about identifying new treatments, identifying new ways to repair the lung after injury in our patients with chronic lung disease.
There's many more possibilities now of what could be helpful.
Because now we can actually generate and test therapeutics in vitro in ways that we could not do before.
Rather than using the stem cells, I would anticipate that we'll use the growth factors that those stem cells require. And these are real drugs that you could actually inject or maybe even take as a pill. Much easier to develop, much easier to deliver, and probably also a lot less expensive in the end.
We can actually think about developing therapies that will do something that we've never done before, which is actually improve lung function, not just help people feel better and not get worse, but actually help people be improved in their ability to breathe.